Today we're going to do a little review of valence electrons and then talk about how that allows us to draw electron dot structures or Lewis structures. So this is a table you've seen before, and the little dots around each of the element symbols represent valence electrons. So even though some of these elements have more electrons than what are shown here, these represent the ones in the outermost shell. And this is organized by the periodic table, so you can see here in column 1, all of these have one valence electron, and if you remember, this ties back to what kind of ion they make. These all make a +1 ion because they lose one electron to have a completely full shell. And then as we go across, we get 2 electrons in column 2. We're going to skip over the transition elements, and then in column 3, these all have 3 valence electrons, 4, 5, 6, 7. And then in the last column here, all of these atoms have a full valence shell, which is why they don't react, right? And then we also talked about how some of these frequently will make just ionic compounds. So the metals, since they don't have very many valence electrons, they can't share to get a full shell. So those only make ionic compounds, whereas the nonmetals can either take electrons or sometimes they share. And so what we're going to talk about today is how they share those electrons and make compounds. Now we can combine the electron dot structures that I just showed you on the previous page to make formulas that show us how atoms are going to bond with each other. So for example, here we have CH4, and if we find carbon on the periodic table, carbon has 4 valence electrons because it's in the 4th column, so we'll draw 1, 2, 3, 4 dots around it. And usually we don't start pairing up until we get more than 4. All right, and hydrogen, if you remember, has 1 valence electron, and so we can draw that on any side. Okay, so it seems like a logical thing to pair up these 2 electrons so that each of those have 2 electrons in that region. So when we draw the electron dot formula for carbon, or for methane, which is CH4, what we end up with is carbon with 2 electrons being shared with 1 hydrogen, 2 electrons being shared with another hydrogen, and 2 electrons being shared with the last 2 hydrogens. Okay, and so that is our electron dot formula or Lewis structure for methane. We can also draw these with each dot being represented by a line. That line represents 2 electrons. Okay, so methane can be written like either of these 2 ways. All right, so let's do another example. If we take a look at water, oxygen, so first we're going to draw the electron dot structures for each of the ones we're starting with. So oxygen has 6 electrons, 6 valence electrons. Okay, so that's what the electron dot formula for oxygen looks like. And again, hydrogen only has 1 electron, and it can only hold 2 total because remember, it only has a 1s orbital. That's all it's got. All right, so we have 2 hydrogens and 1 oxygen. So you can see that hydrogen will pair up here and pair up there, and we'll get oxygen bound to 2 hydrogens like this. Okay, or we could write it this way. And usually the non-bonding pairs are still written as dots since they aren't involved in a bond. So either of these is an acceptable Lewis structure for water. Okay, let's do one more example. So carbon dioxide, carbon again has 4 electrons, and oxygen has 6. And we have 2 oxygens in this case, so we'll draw the second one here. Okay, 2 oxygens. Okay, and so in this case, we could pair an oxygen up with the carbon on this side, and we could pair an oxygen up with the carbon on that side. But now we still have unpaired electrons here and here on the oxygen, and here on the carbon. And so they're going to come together and make a double bond, which we can draw like this. So we have carbon, and it's going to share 2 electrons with oxygen. Oxygen still has its 2 non-bonding pairs. And then it's also going to share 2 electrons with this oxygen, and this oxygen will also still have its non-bonding pairs. Okay, so we could also write this as, I did it shorter for simplicity, but we could also do it as 2 dots like that. Okay, and as we have mentioned in class already, the 2 pairs together in a bond makes this a double bond. Okay, so that summarizes how we make electron dot formulas, and then in class later today, we're going to talk about how to take these structures that are just 2-dimensional and make predictions about what the molecule is going to look like in 3 dimensions.